Welcome to This Explainer. Okay, today we're jumping straight into a really fascinating, honestly, kind of radical alternative model of our solar system's history. We're going to put on our investigative hats and look at a perspective that completely challenges the conventional understanding of how our planetary neighborhood evolved. We'll be drawing on the intriguing work of astronomer Thomas van Flandern, along with researchers Richard Hoagland and Michael Bara. The main focus for us today: what exactly is the exploded planet hypothesis, and what does the physical evidence from Mars actually say about it?
Okay, let's dive into this. Have you ever looked at the asteroid belt? You know, that massive ring of rocky debris floating between Mars and Jupiter, and wondered where it actually came from? The standard textbook models suggest these are just leftover building blocks from the dawn of the solar system, stuff that never quite managed to pull together into a planet. But what if they aren't just spare parts? What if, as the sources we're exploring today suggest, the asteroid belt is actually a planetary graveyard? It's a wildly provocative question, and it's the foundation of the whole mystery we're unpacking right now.
So, here is our roadmap. We'll start with the exploded planet hypothesis, then look at some bizarre anomalies on the red planet. From there, we'll explore the idea of Mars as a captured moon, the sudden destruction of Planet V, and finally, the physical scars of a cosmic catastrophe. Let's kick things off with Section 1, the exploded planet hypothesis. To make sense of the mysteries on Mars, we really have to start with a framework proposed by the late astronomer Thomas van Flandern. The core of his work is the exploded planet hypothesis, or EPH. Basically, it's an alternative model proposing that former fully formed planets right here in our own solar system were utterly destroyed in the distant past. So, according to van Flandern, the asteroid belt and the comets we see today, they aren't primordial leftovers at all. They're actually the shattered, orbiting shrapnel of real planets that violently broke apart.
More specifically, van Flandern's model argues for the existence of two completely lost worlds in that massive gap between Mars and Jupiter. He named them Planet K and Planet V. Based on his calculations tracking comet orbits and meteorite exposure ages, he proposed that Planet K was destroyed roughly 250 million years ago. And what's wild is that date intriguingly lines up with the Permian-Triassic mass extinction here on Earth. Then you have the second world, Planet V, which was destroyed roughly 65 million years ago. And if that number is ringing alarm bells in your head, well, it absolutely should. It perfectly coincides with the K/T boundary event, literally the exact catastrophe that wiped out the dinosaurs.
Which brings us to Section 2, Anomalies on the Red Planet.
So, you're probably wondering, how does a theoretical, exploding planet millions of miles away have anything to do with Mars? Well, we have to look at the massive geological mysteries on the Martian surface itself, and this brilliantly illustrates exactly what planetary geologists are dealing with. Check out the topographical mapping from the Mars Orbital Laser Altimeter, or MOLA. The visual difference between the two halves of the planet is just stark. I mean, it's almost as if you took two entirely different planets and just glued them together at the equator.
Let's break that contrast down a bit. The northern hemisphere is incredibly smooth. It sits at a very low elevation, and it contains a measly 7% of the planet's total craters. But the southern hemisphere? It is violently cratered, with tons of overlapping impacts, and its crust sits an average of 30 kilometers higher than the north. These two drastically different halves are split by a really sharp 35-degree boundary called the line of dichotomy. Now, conventional theories usually suggest the north lost its original crust to some ancient internal heat flow. But researchers Hoagland and Bara suggest a much more dramatic external cause for this whole contradiction.
Let's get into their theory in Section 3, Mars as a captured moon. So, authors Richard Hoagland and Michael Bara took van Flandern's hypothesis and stretched it to explain those incredible Martian anomalies we just talked about. They propose that Mars wasn't always a solitary planet floating on its own. Instead, well after the solar system formed, Mars was actually captured by the gravity of the much larger planet V. In this model, Mars became a satellite. It was a moon. Over millions of years, the gravitational dance between the two bodies forced Mars into a synchronous orbital lock. That means the exact same side of Mars always faced planet V, exactly the same way our own moon always shows the same face to Earth.
Now, what's really interesting about this slide is the physical toll that kind of orbital lock takes on a planet. We see two massive elevations on Mars, the Tharsis Bulge and the Arabia Bulge. Notice where they sit. They are exactly 180 degrees apart.
The authors argue this is absolutely not a coincidence. If Mars were tidally locked to a massive planetary companion, immense gravitational tidal stress would essentially stretch the planet's very crust, inevitably creating these exact opposing bulges. It's like a giant gravitational tug-of-war.
And the evidence for this tidal lock doesn't stop at the rock formations. Recent mappings of dark, subsurface water flows, which are often called stains, cluster perfectly around these two tidal nodes, Tharsis and Arabia. The authors theorized that when Mars was locked to planet V, vast ancient oceans were pulled by that immense gravity and held in place at these opposing ends of the planet. Plus, they proposed that Valles Marineris, which is the largest canyon in the entire solar system, by the way, was actually carved out as an ancient eastern tidal bore. Basically, it was formed by oceans violently sloshing against the rising crust right after Mars was first captured.
Things take a dark turn in Section 4, the destruction of Planet V.
If this model is accurate, Mars's stable life as a warm, wet moon came to a very sudden, terrifying end. The authors outline a timeline of sheer cosmic terror here. Step 1, Planet K and Planet V suffer an unimaginable collision, completely shattering both worlds. Step 2, within hours, literally hours, a devastating blast wave of planetary debris crosses the orbital gap and slams into Mars. Step 3, the sheer kinetic force of this barrage actually causes Mars to tilt 60 degrees on its rotational axis. Step 4, as millions of tons of high-velocity mantle material hit the Martian atmosphere, it superheats, boiling away and blowing a massive fraction of the atmosphere right out into deep space. And finally, Step 5, with the atmosphere suddenly gone, temperatures completely plummet, and those remaining tidal oceans flash freeze exactly where they were being held.
Finally, we look at the aftermath in Section 5, Scars of a Cosmic Catastrophe. Obviously, that's a blockbuster scenario, but what evidence is there today to support a day of such unbelievable destruction? Well, the authors argue the fingerprints are literally everywhere. Remember that strange line of dichotomy we discussed earlier, where one side is super smooth and the other is just a heavily cratered mess? In this model, that line isn't the result of some slow, creeping geological process. It represents a sudden blast wave boundary. Because Mars was tilted 60 degrees on its axis during the event, the barrage of incoming shrapnel from Planet V pelted almost entirely one hemisphere. That left the northern plains relatively untouched, but utterly devastated the south.
Then, you have the chemical evidence. Just think about this number, 43. The surface soil of Mars has 43 times more sulfur than the surface of Earth. To put that into perspective, that is a staggering anomaly. The authors posit that this isn't even native Martian sulfur. This is chemical evidence of a literal rain of primitive core material from a shattered neighboring planet.
And the sulfur definitely isn't alone. Surface iron on Mars measures over 15%, compared to Earth's 3.8%. You also have widespread, unweathered olivine across the surface. Olivine is a mineral from deep inside planetary mantles that quickly breaks down in water, which means it absolutely had to have been deposited after Mars lost its oceans. The authors claim this primitive basaltic coating on the southern hemisphere is actually the infalling mantle debris of Planet V. Even Mars' bizarre magnetic striping is explained here. They suggest the simultaneous, brutal barrage of debris created seismic standing waves that reverberated through the crust, like a ringing bell, locking in a magnetic pattern as the rock flash-cooled.
We've covered a ton of ground today, looking at how the exploded planet hypothesis attempts to tie together the origins of the asteroid belt and the baffling geology of Mars into one grand catastrophic narrative. Now, we are not here to say this model is the absolute, unquestionable truth, but it forces us to ask a deeply provocative question. If this model holds even a fraction of the truth, what else in our solar system's history has been completely misunderstood? It's a mystery that leaves you eager to look up at the night sky and wonder just what really happened out there in the dark. Thank you so much for joining me for this explainer.